All right, this is, I think we ended up at 9, right? 8 and 9 yesterday. So let's go through this. Write the equation we didn't do any of this stuff, right? Point slope form? Okay. Okay. So point slope form right there is this. It's y minus y1 equals m times x minus x1. Something that you have to know. I'm not going to write it down for you, okay? You need to know what that is. So let's just do this problem with that equation right there. It says this line has a slope of -3/2 and it goes through the point 7, -3. So this is my x1 and that's my y1, and of course that is the slope, so that's the m. All right, and basically we just take those numbers and plug them in for those letters, and then we're done. We don't have to do any math on it or anything, okay? You just plug it into that formula and then you're done. So it's y minus y1. What's our y1? -3. Now you could do this. What's minus a negative? It's plus. Okay, so you could do that. Equals m. What's our m? -3/2. And then it's x minus x1. So I put an x here minus x1, which is 7. And then I'm finished. That's it. That's all you have to do. You don't have to solve for y or anything like that, because then it wouldn't be in point slope form. So this is all you want to do right there. Okay? All the rest, I believe, yep, all the rest are slope-intercept form. So that's the real important one. Yep, and y equals mx plus b is the slope-intercept form. And let's just do number 11. It says, write the equation slope-intercept form, y equals mx plus b, of a line having this slope, so that's our m, and going through this point, -5, -6. Now you could do it two ways, but I'm just going to, I tell you what, let's do it. Let's use the point slope form. Even though it says write it in slope-intercept form, let's actually use this form right here to figure it out, okay? But we're going to have to change it into this form. So we're basically just going to have to take this and solve for y, okay? I think it might be the easiest way to do this. So let's take a look. Let's still use the point slope form. And how do you know, or how do I know that I would actually use the point slope form? Because they give you a what? A point and a slope, right? So if they give you a point and they give you a slope, wouldn't it make sense to use the point slope form? Yeah, absolutely. All right, so let's use it. So it's y minus y1. What's our y1 here? It's -6. Of course, that's the same as plus 6, right? Equals m. What's our m here? 3. And then x minus x1. What's our x1? It's -5. And that's going to go to plus 5, right? Now, you don't want to leave it like that because the question says to write it in what? Slope-intercept form. Is it in slope-intercept form right now? No, it's not. So how do I take this and make it like that? Yep, you could distribute here and then get rid of the 6, right? All right, let's just do this. Yes, sir. Yeah, hold on. 3x plus what? No, 15. You got to distribute the 3. All right, so we subtract a 6 from both sides. And then y equals 3x. What's that? Plus 9. Now it's in slope-intercept form, isn't it? So we started off in point slope form. That's not too hard, is it? Started off in point slope form, and then you change things around just a little bit to make it into slope-intercept form. So if they give you a point and a slope, I would use point slope form right here. That's point slope form. And then I got to get y by itself to make it slope-intercept form.
So you just multiply x and 5 and 3 inside of it. That's going to make x.
Yeah, distributive property. Remember that? 3x and then that right there. That's how I got that thing right there. Subtract 6 from both sides to get y by itself, and then there you go. We good with that? All right. Where are we? Right here. Now look at this one. Number 12 says, write the equation in slope-intercept form again. So again, it's y equals mx plus b of a line that passes through these 2 points. Now they give you 2 points here, and they don't give you the what? The slope. But what can we do? Yeah, you can actually find the slope, can't you? So let's do this. Let's get rid of this stuff. So we're doing 12. So we've got these 2 points, so we have to actually find the slope. They don't tell you the slope, but you should know how to find the slope, right? You had several questions earlier on to find the slope, okay? Remember, it's rise over run, or change in y over change in x. So you subtract the y's, put it on top, you subtract the x's, and you put it on the bottom, okay? Watching? Wasn't it odd to you that it was completely quiet and I wasn't saying a word? You still kept on talking. All right, let's do this. So we got to find the slope between those 2 points right there. So we subtract the y's from each other. So we're going to go -4 minus 8, right? Because that's a y, isn't it? And that's a y right there. So you subtract. And then on the bottom, you subtract the x's from each other. That's an x and that's an x. So you subtract them in the same order. So it's 2 minus 5. -4 minus 8 is -12. 2 minus 5 is -3. Do we leave it like that, though? No. First of all, what's a negative over negative? It's positive. And what's 12 over 3? It's positive 4. Okay? Now, that's not your answer. That's your what? That's your slope. Now, what do we want to do? Yeah, we got to do that slope-intercept form thing. Okay? So we got to make it look like this. Y equals mx plus b. There's a couple ways you could approach this. You could actually go point slope if you wanted to. Point slope form. Use this as your slope and use either one of these as your point. But then you'd have to put it back into y equals mx plus b. What I'm going to do is this. Just to change things up a little bit. You know your slope, so that's going to go in for m. What else do you know? Do you know an x? Yeah, pick either one of these points. Which one would you rather pick? It doesn't really matter. The 2, -4?
Yeah.
Would you?
I don't know.
I'd probably pick the 5, 8. Why would you pick the 5, 8? Because they're both positive. Do you have to pick the 5, 8? No, you could have picked the 2, -4, but it might be a little bit easier, I think, to just stick with positive numbers. Wouldn't you rather deal with positive numbers than negative if you didn't have to? Yeah. So let's put this stuff in here. What are we going to put in for y? So we're picking this point right here, 5, 8. What's the y? It's 8. Equals m. We just found the m, didn't we? What is that? It's 4. Multiplied times the x. What's the x here? It's 5. And then, what don't we know? The b. What is the b? What does that stand for? It's the y-intercept. Good. So I've got 8 equals 20 plus b. Subtract 20 from both sides. And b is, what's that, -12? Is that my answer, b equals -12? No. I want to do this. I want to find the slope-intercept form. Okay? So that's my y-intercept. That's the y equals mx plus b. That's the b. All right, so it's y equals m. What was my m? 4. And then x. And then what's my b? -12. And then that is how you do it. Yes? No. All right, number 13. Oops. Okay. All right, let's get rid of all this mess. All right, let's do this one. This one's a little bit different, but it's kind of the same as 12, but you have to figure something out first. See where it says the x-intercept? It's where it crosses the x-axis. So if I drew a little x and y axis right here, and if I had a line, it's going to cross the x-axis at -6. We'll just say it's right here. What's the actual point? If my line crosses the x-axis at -6, what's the ordered pair at that point? -6, 0, right. Okay, and it says it has a y-intercept of 2, so where's that going to be? Probably about right there. And what's that point? It's 0, 2. All right? That's basically the only thing different about 13 compared to 12. It's actually a little easier. So here's my line. My line actually goes through like that. Okay? It goes through like that, and we got to find the equation of that line. Well, we already know one thing. Out of the two things we need to know, remember y equals mx plus b? What's the one thing we already know without doing any math whatsoever? The y-intercept, right. The y-intercept is 2. So where does that go? It goes in for the b. So it's going to be y equals, we'll just do the mx and then what? Plus 2. So really, what's the only thing we have to find here? Yes, sir. If it doesn't say to graph, you don't have to. All right? So how do I find the slope? Well, I got my 2 points, and then I just do the slope thing, right? All right? So what's the slope? It's the change in y over the change in x. What's the change in y? Let's do this. 0 minus 2. And what's the change in x? Negative 6 minus 0, right? And that's negative 2 over negative 6. What does that reduce to? How about 1/3? And so there is your equation right there. Y equals 1/3 x plus 2. All right? We good? Okay. Let's talk about 14. Look at this. I don't know if you remember this or not. I hope you would, but what does it mean when it says it's perpendicular to this line? Two lines that are perpendicular to each other. Thank you. If I have two lines, right here and they're perpendicular to each other, what's true about their slopes? If these two lines are perpendicular, they're negative reciprocals of each other, right? So let's say the slope of this line was, I don't know, 2/3. Okay? What's the slope of this line that's going up and down like this? That's right. It's the negative reciprocal, which means I change the sign. All right? So it was positive. I change it to negative. And I flip the fraction. So it's negative 3 over 2. So anytime lines are perpendicular, their slopes are negative reciprocals of each other. So if this was 2 over 3, this is negative 3 over 2. All right, let's take a look at this. Write the equation of slope-intercept form for a line that passes through this point right here and is perpendicular to this line. So if the line that I'm trying to figure out is perpendicular to this line, what can I figure out really easy? I can figure out its slope, right? That's right, because look at what the slope of this line was. The slope of this line was what? 2. So how do you find the slope of a line that's perpendicular? You change the sign and you flip it. So it was positive, so now it's what? Negative. It was 2 over 1, and now what is it? It's 1 over 2. So that's the slope of the line that I want to figure out. Now, they give you a point, and now you know the slope. You can actually find the equation of that line. If you wanted to use point-slope form, you could. Let's just do it the way we kind of did this over here. Let's do the y equals mx plus b. Well, we know the b, which is negative 1/2. I'm sorry. I don't know why I said that. The slope is negative 1/2, so we have to find the b. All right. So what is the y? If I'm using this point right here, what is my y? It's negative 1. Equals the slope, just found it, it's negative 1/2, times the x. What's the x? It's 8. And then plus what? B. And I'm going to find b. So it's negative 1. What's half of 8? 4. And then it's negative, so it's negative 4. Everybody with me? Add a 4 to both sides. And what's b? No, it's positive 3. So we want to write our equation now. So how are we going to write it? Y equals, what's my slope? Negative 1/2. Then x, and what's my y-intercept? Positive 3, and that's how we do that. Just for the sake of time, I'm not going to do 15, but this says it passes through this point and it's parallel to this. So the slope would still be 4, that's right. Okay, because remember, if two lines are parallel to each other, they have the exact same slope, don't they? Okay, so you wouldn't change that slope. The only time you change the slope is it says if it's perpendicular, right? It's really not that hard, is it? You just look at this and you say, oh, the slope is 4. Put in this point right here, 0, 7. Actually, to tell you the truth, they make this kind of easy. Because if they tell you a point is 0, 7, where does that lie? It lies on the y-axis. So that is your what? That's your y-intercept. Okay? So really, you could do this with very limited amount of work. What's the slope? 4. What's the y-intercept? 7. So let's put it all together. Y equals what? 4x plus 7. Wasn't that nice and easy? Yep. Okay. I take that as a yes. That was nice and easy. No, on that one. All right, let's take a look at this. We kind of talked about this earlier, or yesterday actually, but talked about lines that are parallel to each other. Okay, so if that's parallel to that, what do I know about this and this? They're consecutive interior angles, and they do what? They add up to 180. Okay, so I'll let you do the math on this just for time's sake. Making me really upset. So you got 2x plus 6. Don't set it equal to 130. They're not equal to each other. Look, this is an obtuse angle, isn't it? And this is what? An acute angle. Can an obtuse angle be equal to an acute angle? No. So what do? You add them up, and you set them equal to 180. And you should be able to do the math and solve for x there. Okay? So you got to know that they're consecutive interior angles. What about this? What are these two angles? They're both acute, aren't they? So they're both equal to each other. So they're actually equal to each other. So how do you set that up? Just 4x minus 10 equals 3x plus 10, and then you just solve. I'll let you solve that yourself. Let's take a look at this one. Got writing all over it, but what's true about this angle and this angle? They're both acute, so they're both equal to each other, right? So if they're equal to each other, what do? Set them equal to each other and then solve. So 8x minus 8 equals 6x plus 4. You do your math, and you're good to go. Nah, that's not really plug and chug. Alright, let's see what this is about down here. I made this really easy for you. Look, it says copy the figure on your answer sheet, okay, whatever. But it says construct a segment that represents the distance that's indicated. The distance from C to AB. Now, if I have a point, let me just do this for you. If I have a line and I have a point, how would I draw the distance from that point to that line? It's got to be perpendicular. That's not the distance, is it? That's not the distance. Where is it? People say straight down, but what's a better way to say it? Perpendicular, okay? So that would be, now if I don't put the little box there, do you know it's perpendicular? No, so you need the little box right there. So where am I going from and to? I'm going from point C, and I'm going to line AB. And I have to draw it so it's perpendicular. Now if I just do that, is that enough? No, it's not. And then, boom. Doesn't matter what side you put the box on. Okay? But you have to have that line. You have to have that line, and you have to have that little box right there. What's that? He knows what I'm talking about. Look, from point D to line AB. From D to AB. Now watch. Am I going to go like that? Am I going to go like that? That's right. You're going to have to take AB, and you're going to have to extend it, aren't you? So you got to extend that out. And now I can go from D to AB. But again, what do I have to do? I got to go D perpendicular. Don't say straight down. Just discussed that a second ago. From D to the extension, but I got to have that little right angle box there. Okay, that shows it's perpendicular. If you don't put the little box there, it's going to be wrong because it has to be shown that it's perpendicular. All right, there you go. So that was chapter something, whatever it was. 3. It's classified by its angles and its sides. So look at ABD. Let's make this a little bit bigger. ABD, triangle ABD. What is it by its angles? Okay. You could say it's equiangular. Now, it doesn't tell you anything about the angles, does it? Okay, but you know the angles are all equal because the sides are equal. Okay, so you know that all three angles are equal to each other. So you can call it equiangular. You could also call it what? No, by its angles. You could say that it's an acute triangle, right? You could say it's an acute triangle. You don't have to have both of them. Just one or the other is fine. Now let's classify it. Lucas, I've had enough. Right here. Oh, yeah. Sorry, I haven't warned you enough. I only warned you like 4 times today. Okay, so now we got to talk about it by its sides. Now look, all 3 sides are equal to each other, so equilateral, right? Equilateral. Or you could also say isosceles, because remember isosceles is at least 2 sides are equal to each other. So you could call it equilateral or isosceles, either one. What about BED? BED. By its angles. By its angles. It's not acute, because what kind of angle is that? That's obtuse, so it's an obtuse triangle. Okay. What about by its sides? Isosceles, because 2 sides are equal to each other. BE and ED are equal to each other. That's 2 sides. That's isosceles. Right here. What is that? It's obtuse. Okay, what about the next one? EDC. EDC. That's this little one right here. Yeah, it's a right. By its angles, it's a right triangle. What about by its sides? You got 1 tick mark, 2 tick marks, and no tick marks. Scalene, right, because you don't know that any of the sides are equal to each other. So it's a scalene triangle. Okay? Let's take a look at this part. I'm just going to set it up, just again, due to time. It says ABC is an equilateral triangle, which means what? All 3 sides are equal. Look, they give you one side, the second side, and a third side. So if they're all equal to each other, then you set them equal. Now, you don't set all 3 equal to each other. You just pick 2 of them. Right, and it doesn't matter which 2 you pick. Okay, it doesn't make any difference. Okay, so I'll do this. I'll take 8x and set it equal to, yeah, let's do the 7x plus 3. That might be a little easier. Subtract 7x from both sides, so x equals what? 3. Now that's one of your answers, isn't it? Because look what it says. Read the instructions. It says find x and what else? The measure of each side. It's a triangle, so how many sides do they have? 3. So there's one answer. I got to have 3 more answers. How do I find what the lengths of the sides are? Now I can plug and chug, right? Now what's that? I subtract 7x from both sides. I said that. I subtract 7x from both sides. 8x minus 7x is 1x. Shh, don't talk, please. I'm talking. You subtract 7x from both sides. 8x minus 7x is 1x. X equals 3. And now you take this x and you plug it in for here. So what's AC? 8 times what? 3, which is 24. So AC is 24. Without doing any math whatsoever, what is BC? What's AB? How do you know they're all 24? Because it's equilateral. That saves you doing all the work, right? There you go. This says it's an isosceles triangle, and they tell you which 2 sides are equal to each other, LM and LN. So you can't pick any of the 3 sides to set equal. You can only pick the ones that are actually equal. So you set 5x plus 5 equal, we'll do it up here, 5x plus 5, and you set it equal to 2x plus 20. Subtract 2x from both sides, what do you get? 3x. Subtract 5 from both sides, you get 15. You divide both sides by 3, so x is 5. So that's one of your answers. Then you got to find the other 3 sides. So let's plug it in. So x is 5. Plug it into here. 5 times 5 is?
25.
Plus 5 is?
30.
30. So that's 30. Now, these 2 are equal to each other, so it should be what?
30.
Without doing any math at all. If you want to make sure it is, you could always plug it in. 2 times 5 is 10, plus 20 is 30. Now, this one you don't know, so you definitely got to plug it in. Plug in a 5 for this. 9 times 5 is?
45.
Minus 5 is? 40. So you got 4 answers, don't you? You have x equals 5, and you got LM, LN, and MN. So you must have all 4 of those there to get that right.
What I think that would be like 30. Like, it would what? X equals 5 and 30 and 40. Because
Well, you gotta show that LM is 30 and LN is 30. You got to have 4 answers. So what do you think that means if you just give one of those? Means you didn't get it right. Let's take a look at this. Angle 1. Let's look at angle 1 right here. This is an exterior angle. Do you remember doing this? Exterior angles, remote interior angles. This is an exterior angle. Okay, so it's equal to the sum of the remote interior angles. I think we even talked about this the other day, didn't we? On another, did we? I don't know. Maybe it was the other class. So this is an exterior angle. So what's the one simple little math thing I have to do? Add up 56 and 37. So 56, let's make this a little smaller. 56 plus 37, that's a 13, that's an 8, it's 93. So that's 93 degrees. Okay? You can get angle 2 pretty easy too. If this is 93, look, this whole thing makes a straight line, doesn't it? So that's 180. So it's 180, what? Minus 93. That's 87. So angle 2 is 87 degrees. Everybody with me? Now you got to find angle 3. You could find angle 3 a couple different ways. But watch this. What I would do, a lot of people were saying this in my other class when we were going over this. They said, well, add these 2 up and then take them away from 180. All right, you could do that. Or one step. You could do this in one step instead of 2. This is also an exterior angle, and these are remote interior angles to this exterior angle, isn't it?
Yeah.
Oh, wait a minute.
Yeah, you're right.
Let's see if it is, actually.
You're right.
I don't think I am.
87 is an exterior angle.
32 degrees.
No, not the 87. The 93 is.
To the office?
Okay.
Thank you.
It's not the 87 because, look, you can only extend one
Oh,
side.
you
Look.
put 87 to waste
Actually, no, that's... Oh, that's that time already?
Bye.
I have my book here for you.
Yeah,
What's that?
I have to give this to you. Today's my last day.
What? Your last day? Where are you going?
I'm going to Mount Pleasant
Mount Pleasant. Why would you want to go to Mount Pleasant?
because it's in my district.
Oh my goodness. Okay, I'll take it. Thanks.
Thank you.
Hey, yo, quick Sean, stop yelling at us.